On our next example, we have to evaluate the determinants using the cofactor expansion here. So we have as an introduction example a 3 by 3 matrix. Wherein applying the cofactor expansion, so we have to consider a certain row or a certain column to be deleted. Now in this example, I chose the second row as the one to be deleted. And then we have to look for the cofactor for the elements on the second row and first column, second column, and the third column. So if we will start from the cofactor of the element at second row, first column, so we have to delete the second row and first column. Then the elements remaining are negative 3 and 3, and it will serve as the elements on the first column of the minor factor, and 3 negative 2 as the elements in the second column of the minor factor. And then the cofactor will be negative 1 raised to the sum of the second row and first column, which is cube. So we have negative 1 raised to cube is negative 1, and then to be multiplied by the determinant or the minor factor by evaluating the determinant of a 2 by 2 here, which is negative 3 times negative 2, and that will be positive 6, minus 3 times 3, and that will be negative 9. So the answer is negative 3. Therefore, the cofactor of the elements at second row and first column is negative 1 times negative 3, positive 3. And the next is we have to delete the second row, second column, and that will be negative 1 raised to 2 plus 2, and that will be 4. So negative 1 raised to 4 is positive 1, and then multiplied by the minor factor, meaning the elements or determinants of the elements remain after deleting the second row and the second column. So deleting the second row and second column, the elements remain are 4, negative 3, 3, and negative 2. So we have it here, evaluating the determinants by multiplying the principal diagonally downward. That will be 4 times negative 2, and that will be negative 8, minus the principal diagonally upward. That will be negative 3 times 3, that will be negative 9. So we have negative 8 plus 9, that will be positive 1, to be multiplied by negative 1 raised to the 4th, which is positive 1. So then the cofactor of the element at second row, second column is 1. Next is the cofactor of the second row, third column. So we have to delete the second row and third column. The elements remain are 4, negative 3, and that will be served as the first column of the minor factor, and negative 3 and 3 as the second column of the minor factor. So for the cofactor of the element at second row, third column is now negative 1 raised to 2 plus 3, and that will be 5. Then negative 1 raised to 5 is negative 1, and evaluating the determinant as the minor factor is now 4 times 3 downward, and that will be 12, minus the upward negative 3 times negative 3, that will be positive 9. So we have 12 minus 9, the cofactor, minor factor is 3, to be multiplied by negative 1, so then the cofactor is negative 3. Therefore, the cofactor expansion in evaluating this 3 by 3 determinant now is the element at second row, first column is 6, so multiplied by 6 with the cofactor at second row, first element, which is 3. And then the element at second row, second column is negative 4. So we have to multiply the negative 4. This is actually the element at ij. Negative 4 times the cofactor, which is positive 1. And then when we deleted the second row, third column, the element is 5, to be multiplied by the cofactor, which is negative 3. So adding the 6 times 3, 18. With negative 4 plus 1 is negative 4, plus 5 times negative 3 is negative 15. So the determinant now is equal to negative 1. And then for the other example, we have it here, a 4 by 4. Again, you have to choose a certain row or a certain column to be deleted. Now, in giving you a hint which row or which column to be deleted, Now, as you can see here, I deleted the third column because it consists of 2 zeros. So if there will be a row or a column which consists many zeros, it is better to consider that as your row or as your column to be deleted. So here I chose the third column as the row to be deleted, and then we have to look for the cofactor from the first row, third column, second row, third column, third row, third column, and fourth row, third column. So then, by applying the cofactor expansion, the determinant of this matrix A, which is a 4 by 4, is now equal to, when we deleted the first row and third column, the element is 4. So this is 4. And then multiplied by the cofactor, which is the cofactor, this is negative 1 raised to 1 plus 3. And then multiplying with the minor factor, which when we deleted the first row and third column, the elements remain are 3, 0, 2, and it will serve as the first column, 1, 1, negative 1, the second column, and 1, 0, 1 as the third column. And then we have to delete next as the second row and third column. And the element on that position is 0. To be multiplied by the cofactor, which is negative 1 raised to second row, third column. And multiplied by the minor factor, which are the elements remain when we deleted the second row and the third column. So the elements are 2, 0, 2, 3, 1, negative 1, 1, 0, 1. So these are the elements for the minor factor. Plus, then the next one is, we have to delete the third row, third column. So then the element is negative 1. And then to be multiplied by the cofactor, which is negative 1 raised to third row, third column. And then multiplied by the minor factor, where the elements are, when we deleted the third row, third column, the elements remain are 2, 3, 2, 3, 1, negative 1, and 1, 1, 1. And then when we deleted the fourth row, third column, the element is 0. To be multiplied by the cofactor, negative 1 raised to fourth row, third column, and multiplied by the minor factor, remaining elements after deleting the fourth row, third column are 2, 3, 0, 3, 1, 1, 1, 1, 0. Then as you can see here, if we evaluate, we can neglect right away the cofactor by multiplying the element 0 here. So these are equal to 0. Then all we have to do is just evaluate the non-zero. And this is now equal to, when we evaluate the determinants here, by using the basket method, meaning all we have to do is just rewrite the first column and the second column, then we can evaluate right away the 3 by 3 determinants by multiplying the principal diagonally downward. 3 times 1 times 1, that will be 3. 1 times 0 times 2, that will be 0. 1 times 0 times negative 1, that will be 0. Minus principal diagonally upward. So we have 2 times 1 times 1, that will be 2. Negative 1 times 0 times 3, that will be 0. 1 times 0 times 1 is 0. And then to be multiplied by the element, which is 4. And then plus, we have it here as negative 1 because negative 1 raised to the 6 is positive. To be multiplied by negative 1 here. So this is still negative 1. And then again, also, we have to evaluate the minor factor. Since this is another 3 by 3, so all we have to do is just rewrite the first column and second column. And then we have to multiply the principal diagonally downward. 2 times 1 times 1, that will be 2. 3 times 1 times 2, that will be 6. 1 times 3, negative 1, that will be negative 3. Minus principal diagonally upward, 2 times 1 times 1, that will be 2. Negative 1 times 1 times 2, that will be negative 2. 1 times 3 times 3, that will be positive 9. And then here, simplifying, we have 3 minus 2, that will be 1. So 4 times 1. And then we have it here. 2 plus 6, that will be 8. Minus 3, that will be 5. Minus, this is already 9. So we have negative 4 times negative 1. And that will be positive 4. So we have it here 4 plus 4. So the determinant of this 4 by 4 matrix A is now equal to 8 using or applying the cofactor expansion.